Windows 11 is currently losing market share as users push back against aggressive telemetry, system bloat, and hardware requirements that make relatively new machines obsolete. This chaotic landscape stands in contrast to the era of Unix. Born inside the regulated monopoly of Bell Labs, Unix was an elegant, modular environment designed for systems like this digital VAX. That uncorrupted vision ended in 1984. The antitrust breakup of AT&T shattered the unified Unix ecosystem, turning it into a collection of proprietary products and legally contested intellectual property. This fragmentation created a power vacuum. Computing was entering its most explosive growth phase, but the most stable operating system in existence was suddenly tied up in corporate litigation. IBM moved to dominate the hardware market through standardization, but they treated software as a secondary commodity. They left the door open for an outside vendor to control the logic of the machine. Microsoft seized that opening, pushing DOS and eventually Windows onto the global market. It was an architecture that lacked the permissions, networking discipline, and stability of Unix, but it was what IBM's hardware needed to ship. In response, Richard Stallman launched the GNU project to build a free userland. When Linus Torvalds released the Linux kernel in 1991, the movement finally had the low-level code required to actually boot a complete free system. This completed system represented an existential threat to Microsoft. For the first time, a legally free, Unix-like alternative could run on standard PC hardware, bypassing Microsoft's licensing fees entirely. Internal Microsoft memos leaked in 1998, the Halloween documents, reveal that the company secretly recognized open-source software as its most dangerous competitor. To counter this, they deployed a strategy of fear, uncertainty, and doubt. In 2003, Microsoft paid the SCO Group for a Unix license at the exact moment SCO was preparing to attack the legitimacy of Linux. That capital empowered SCO to sue IBM and threaten enterprise Linux users, claiming that the Linux kernel was legally contaminated with stolen Unix code. Microsoft further divided the market by signing patent deals with companies like Novell. This created a two-tier system, a Microsoft-approved tier that was safe for corporations, and a dangerous tier for everyone else. This proxy war was not designed to win in a courtroom. It was designed to poison the reputation of Linux in the enterprise market, making corporate lawyers too afraid to authorize its use. When the lawsuits eventually collapsed, the strategy shifted. The corporate establishment moved from destroying Linux on the outside to capturing its development from within. IBM committed $1 billion to turning Linux into an enterprise-ready server tool. Simultaneously, Microsoft began absorbing Linux into its Azure cloud, eventually becoming one of the kernel's largest contributors. Historically, Linux was a web of small, independent tools, communicating through simple interfaces. But corporate-backed developers began pushing Systemd, a massive, centralized framework consolidating these functions. Systemd centralized control over the entire system, adding complexity and corporate-friendly telemetry to a once modular environment. The result was an internal transformation. The Rebel operating system was rebuilt into a monolithic, centralized architecture, mirroring the corporate systems it meant to replace. Tech-literate users are now abandoning these compromised systems. They have realized that even if a system is open source, its core direction can still be captured by monopoly interests. The immediate refuge is the BSD family. These operating systems are direct descendants of the original Unix tree, maintaining a strict separation between the core system and third-party bloat. BSD's permissive licensing and its focus on a small, vetted base system keep it free from the legal traps and centralized dependencies that have overtaken the Linux ecosystem. But while BSD is a stable oasis, a permanent solution requires moving away from monolithic kernels entirely. This is why projects like GNU Hurd or Redux focus on a microkernel architecture. By isolating drivers and services into their own restricted memory spaces, they ensure that a failure or a malicious update in one component cannot take control of the entire machine. New frameworks like Sexos take this further. They utilize rigid implementation gates, sets of hard conditions that must be met before any system resource can be accessed. These systems actively ban legacy assumptions. They block raw path-based trust and reject corporate compatibility layers, forcing software to prove its identity at every step. Computing is moving past the era of choosing brands. The focus has shifted towards building decentralized architectures that are structurally resistant to the capture of any single monopoly.